Yeah. Okay, explain why increasing the surface area. Anytime we're increasing rate, basically we're just increasing collisions, or we're increasing the likelihood that a collision will result in a reaction. Remember, they need to collide in the right orientation with enough energy to overcome the activation energy. So, if you have an uncatalyzed reaction, to draw a catalyzed reaction, I just randomly chose a two-step. Two steps because it has two new activation energies. The answer is not always two. I saw that on quizzes, like it replaces it with two faster steps. How do you know how many faster steps there are? I'm just picking two. You could have three, you could have one, it really doesn't matter. You just need to lower the activation energy. Make sure you know which way to subtract for these two things, final minus initial, and then initial minus the top, where the transition state is, all that. I have one more for you tomorrow. That should finish up everything that's on the test for you to practice. Today is lots of algebra. So can you get out your notes, please? What? Your pre-calc test? Did you study? I did study. So she didn't study as much as you studied. I think to do well in like pre-calc and AP Chem, you have to study twice as much as you studied. But more. No, I'm just saying. I know that you're smart and can do things, you just need to do more of that. And let it go. Then who cares? Then take your B. What difference does it make? I'm with you on that. I wish when I was in high school I spent a lot less time studying and doing stuff because none of it matters. Nobody ever asks you any of these things. Okay, thank you. Just to kind of remind you, I keep thinking I should dye this water tube and actually see it. But I don't actually follow through with dyeing the water. Okay, just to remind you, when we have equilibrium, we know we have A and B, and it's turning into C and D. A and B is, this can be important today. A and B is disappearing. I just randomly picked a page, don't worry about it. A and B is disappearing, and it's turning into C and D. So my reactants are going to go down, my products are going to go up. When I reach equilibrium, though, there's nothing that stops C and D from running into each other and turning back into A and B. These two things just happen at the same rate. So to our eyeballs, it looks like nothing's happening. My level of water isn't changing. They're just changing at the same pace. Okay? We learned that when we plug numbers into our K equation, that number means something. When K is really big, that means it lies right, the right side of the product side. I just totally think about it because it's my left, but you're right, right? It lies right, the product side. My eyeballs show, I see with my eyeballs lots and lots of products. If my K is really little, then I have lots of reactants. To my eyeballs, nothing happened. I didn't make anything new, okay? So when the music starts, please just remind each other how I know where the numbers go in the equation. Where does C go? Where does D go? Where do coefficients go? Because that's going to be our first thing we're starting today. Ready, go. These are sample problems. Where are sample problems? I'm lying. We're starting at 11. One more page. Okay, just to practice plugging stuff into our K equation again. But this time, we are not going to be solving for K. We're going to be solving for something else in here. So remembering how to do algebra with cross multiplying and all that kind of stuff. So you have to read the words, figure out what numbers you have, what you don't have to solve for the unknown. Go ahead and do that now with your balance sheet number 11. Ready, go. No. My advice to you is to write smaller. If writing small for you is a struggle like it is for me, grab like an extra half sheet of paper. What we did is we just like did the problem on there and just stapled it in the spot. If you're okay with writing decently small, I made it work. It's just scrunchy. Then you'll be fine. Okay, this is going to be learning something brand new. It involves the algebra that we just did, but you have never ever seen this math before or this type of learning before, so I need you to like really focus, okay? A closed system initially contains 1 times 10 to the negative third molar hydrogen. I know there's a lot of zeros are zeros, so I'm ignoring them on purpose. And 2 times 10 to the negative third molar iodine. At 448, you will always get a temperature. We just haven't done something with temperature yet. It's allowed to reach equilibrium. That means I got to the point to my eyeballs, it looks like nothing happened. My graph is all flat, but really they're just switching at the same speed. At equilibrium, the HI concentration is 1.7 times 10 to the negative third, and we're going to calculate K. We just played a game of calculating K, but now we're doing something different. Reading comprehension. I have 2 different things going on. I have initial time equals 0 concentrations. I have my blue initial and I have some red initials. And then I also have an equilibrium concentration, but of only one thing. Okay? That's why this is different. This isn't all equilibrium concentrations. What I'm going to do is something called an ICE table. An ICE table is I'm going to write the balanced equation. I'm going to work down from it. I'm writing the balanced equation spread out on purpose because lots of things are going to go in here. I said ICE, I-C-E, just in case I'm like hard to hear. I stands for initial. So now I'm going to go back to my words and pick out things that are talking about initial concentrations. A closed system initially has 1 times 10 to the negative third molar hydrogen. I'm getting rid of zeros because they don't matter and they're just going to make things smushy. And 2 times 10 to the negative third iodine. Now you're going to have to think. Initial times 0. Have I made any product yet? No. Nothing has happened. I have not turned any ABs into Cs yet. So I can fill that in as well. My other number, it says at equilibrium. E stands for equilibrium. My HI concentration, HI at equilibrium, is 1.87 times 10 to the negative third. Okay? My next step is to figure out my change. C stands for change. In a balanced equation, the change is always proportional to the mole ratio. We're going to do some mole ratio. So my hydrogen is going to disappear, negative. I know it's disappearing, it's going to go down. By a ratio of 1, because my coefficient is 1, and a factor of I don't know. I'm going to call it X. I don't know what that rate is. My iodine, so this, just to be clear, This learning's hard. This one is because of this one, okay? My iodine is also going to disappear because it's a reactant. They disappear. Add a factor of 1 because the coefficient is 1 by, I don't know how much, I'm going to call it x. To be clear, because learning is hard, this one is because of that one. My HI is going to up here by a factor of how much? 2. This 2 is because of that 2 right there. That seems to be all I know at this point. So now this is where a lot of algebra is going to come in. Equilibrium is here. I need to figure out all of this stuff in between to know how much I end up with. All I know is what I start with. And I know it's going to change at a factor of 1x, but I need to know what this is here. The initial and the change is where the equilibrium is going to end up. So I'm just going to smush those two together. If I start at 1 times 10 to the negative third, and I change at losing 1x at equilibrium, I'm going to have 1 times 10 to the negative third minus 1x. Same here, 2 times 10 to the negative third minus 1x. And same here, 0 plus 2x is going to be at equilibrium. But they gave me my equilibrium concentration. Some way, somehow, this is the whole game of equilibrium, you will get enough information to solve for x. In this case, the words gave me an extra number. They told me that my equilibrium is this, and it has to equal 0 plus 2x, so now I can solve for x. Let me tell you why, and then I'm going to totally let you talk about it. My question is asking me to solve for k. I know k equals my products over my reactants. Any coefficients are going to become exponents. I need numbers to plug into here to actually answer my question. I don't have numbers to plug into there. I have a whole bunch of x's. So some way, somehow, you're going to solve for x. All I want you to talk about is how I got this, and if you can talk about why is it equal to 1.87 times 10 to the negative third. You might not be able to. I'm just going to say, I don't think he is. Okay, now we're going to solve for x. Oh, is that a good one?
Yeah, that's a good one.
Oh my God, I recorded that whole time. That's going to get rejected. I'm concentrating so much on learning. Shoot. Okay. Our next step is to solve for x. So I'm going to use this. I'm going to circle it. I'm going to use this equation to solve for x. They just happen to give us that number this time. It could be anything. Somewhere they're going to give you enough information. They're going to give you an extra number to solve for x. So go ahead with your bad buddy, get what x equals. What does x equal if I have that equation? Push buttons, do it. Okay. All I did was divide by 2, divide both sides by 2, x equals that. Now I can plug x back in for x, and I can plug x back in for x, and get what my equilibrium numbers are there as well. Okay, so go ahead and push the buttons. If you're not going to use the EE button, you're going to have to add extra parentheses, so just make sure your bad buddy knows how to push buttons and do math. Okay, ready, go. Oh, green on green, that was a bad choice. Can you see it? 1.07 times 10 to the negative third. I know, I'm sorry. I regret writing in green and then highlighting green. 6.5 times 10 to the negative fifth. 1.07 times 10 to the negative third. And then I highlighted this one on purpose. Okay. I still didn't answer the question. The question asked me to calculate K. That means I need to get numbers to plug into here, here, and here. These are these. I didn't have them before. I had to do all that math to figure it out. So now plug it in and get an actual answer. Don't forget to square it. It is 6.5. Yep. Careful if you're not using the EE button, make sure your parentheses are sufficient. I'm writing my answer up here. Go ahead and do number 8 with your bad buddy. Same game. Okay, 14. This for sure. If you are even kind of a big writer, you're going to just want to grab a scrap sheet of paper, or you're going to need to concentrate on writing really little. This has algebra that goes like a half a page. Okay. Lots of things to learn about now. Yeah, so either focus on writing little or find a sheet of paper.
A 1 liter flask is filled with 1 mole of hydrogen and 2 moles of iodine. So first thing I'm noticing is I don't actually have molarities. Molarity equals moles divided by liters. 1 mole divided by 1 liter. So it's 1 molar. And 2 moles of iodine, that's going to be 2 molar, because it's all in the same thing. It's in a 1 liter flask at 448. So my temperature, which I haven't taught you what to do with. The value of the equilibrium constant. So now I'm not solving for K, I'm given K, is 50.5. What are the equilibrium concentrations of hydrogen, iodine, HI in moles per liter? I'm going to start with, I got a lot of things going on. I'm going to make my ice table. I like to make it to the right for no reason. I don't know why. I do my ice table over here, and then I do my math over here. I'm going to write it. I'm going to separate it out just so I have some space. Because when things get scrunchy, I get stressed because I don't know where the numbers are. I'm going to use my reading comprehension and go back to the words and figure out where things go. It never says the word initial, so you have to think and read. It says it's filled with it at the beginning or something like that, so that means that these are my initial. 1 mole of hydrogen, and I have 2 moles per liter of iodine. Nothing has happened yet. I have not made any products, so I know this is going to be 0. I'm going to do my change right next because I know how to do change now. This is going to disappear at a rate of 1x. 1 because the coefficient is 1. This is going to disappear at the rate of 1x. 1 because the coefficient is 1. X I'm going to have to figure out somehow how to do it. This is going to appear at a rate of 2x. So I'm looking at reading. I'm not given that extra number this time to solve for x. So I'm just going to go ahead and add down. I am simplifying. That's 1 minus x. Instead of writing like 1.0 minus 1x, this is 2 minus x, and this is just straight 2x. Stop check with your beta buddy. How are you doing? How do you know how to add down to get all of your numbers in? Good so far? Questions? My extra number is my K value. I wasn't given an equilibrium number to solve for x. I'm going to have to solve for it using K. I'm going to start by writing my K equation. Products over reactants, my coefficients become exponents. This is like why it's been good that we like stretched out and warmed our algebra muscles. 50.5 is K equal to HI squared. Right? I plug in my green equilibrium row into here, here, and here. Over H squared, H2 is 1 minus x, times I2 is 2 minus x. This is how I have to solve for x now. Good thing we stretch out our algebra muscles. You have to FOIL this first. FOIL this, cross multiply, distribute, math, 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 math. Don't screw up your negative sign. And I'm going to walk around and just cheer you on. This is going to be, I'm just going to be a cheerleader.
Okay.